Okay, everyone. So we're looking at the last type of charging, looking at static electricity today. So remember, there's 4 in total. So we looked at friction already. We looked at charge by contact. And the last one we're looking at is charging by induction. And there are 2 types of inductions that can occur. Charging by induction using temporary charges. So meaning the charge doesn't stay. It's kind of like a temporary positive or negative charge, and then it goes back to neutral, or causing a permanent charge. So induction can be used for both temporary and permanent situations. Okay, so let's review, or let's discuss what induction means in general. Induction is basically a way of causing electrons to move, okay? So it's like we're inducing the movement. So induction means basically you are forcing the movement of electrons, okay? So when we're talking about induction, we're typically looking at a charged object that is brought close or near a neutral object, okay? So here's the key to induction that makes it different from any other charging type. The induction happens without the neutral object being touched by the actual charged object. So it's being forced to change charges without any touching whatsoever. So if you remember, friction, you have rubbing occurring, and contact, you have touching, right? So you have a charged object touching a neutral object. Induction, you have it coming close, but not touching the object whatsoever. So maybe it doesn't make a whole lot of sense right now, but as we go through, you'll see what we mean. Okay, so we actually already saw this idea of induction when we had that simulator with the charged balloon going close to the wall. So what ends up happening, let's imagine, right? So we have a negative balloon and the wall that is neutral, right? As the balloon is brought close to the wall, the electrons that are in the wall actually move away from the balloon, right? So they are being repelled by the negative balloon. So what ends up happening is right now, this is considered to be an induced charge. The electrons are forced to move because of the repulsion between the balloon and the wall. So what happens is the surface of the wall has what we call a temporary positive charge. So the balloon and the wall are not touching here, but what's happening is because the electrons push away from the surface of the wall, the surface has now a temporary positive charge. Now imagine if the balloon were to go away. The electrons would actually return back to their regular position. So it is induced because the electrons are forced to move, but this is not a permanent charge because the electrons are not transferring anywhere. The electrons just simply move away, and if the balloon were to go away, it would return back to its regular position. Okay, so here's a temporary charge by induction. So here you do not have any contact whatsoever. So here we have a neutral object, a negative rod is brought close. So what happens is the electrons are being repelled by this negative rod. So we can say that this has a temporary positive charge on one side and a temporary negative charge on the other side. Now, if you were to remove the rod, it would actually go back to being a neutral position and have the electrons back in their regular spot. The same thing happens if you have a positive rod. It's just that instead of the electrons moving away, they move closer. So here we have that neutral sphere again. A negative rod is brought close but does not touch. So if this were to touch, that would be charged by contact. Here we are simply bringing it close. So the surface here is a temporary positive charge, but there is no electron transfer. So when that rod is brought away from the sphere again, it will return into its regular neutral position. Okay, so this is just indicating that. So after the rod is taken away, the sphere will go back to being neutral, and the electrons will go back into their regular position. That's why we call this a temporary charge. So technically, this is still neutral. You have equal numbers of protons and electrons, but the surface that's being close here, or I should say that's closest to the rod, has a temporary opposite charge. Okay, so before we look at this with permanent, I want to show you a simulator. Hold on one second. Okay, I'll link this simulator for you on our D12 so you can try this out yourself. So here we have our neutral sphere and a positive charge. So look at what happens when we bring this close by. So notice I'm not touching it. So the electrons that are in this neutral sphere are attracted to this positive rod. So the surface, just ignore that for now. Oh boy. Okay, so I'm going to talk fast about this. So the surface that is closest to this rod has a temporary negative charge in this case. The other portion has a temporary positive charge. And notice only the electrons move. And if we take away the rod, it goes back to its regular neutral position again. So this is a temporary charge by induction. So we're temporarily causing this charge, and then if we lose it, it will go back to being neutral again. Okay, so let's look at it with an electroscope. So same idea, we have the metal sphere, the metal rod, and then our leaves. So as you bring this close, look at what happens. The electrons are attracted to this positive rod, so the electrons move up into the knob. So the knob is temporarily negative. The leaves are temporarily positive. But if you were to take this away, it is still neutral, right? There's no electron change. Okay, so now let's take a look at what happens when we have a permanent charge with induction. So temporary just essentially means you bring a charged object close and then you take it away again. Okay, but there is a way to make a charge change permanent. So to make a permanent charge, the only way to do so is to attach a ground. Okay, so if you remember the symbol we use for grounding, looks like this. So it looks like almost like an arrow pointing into the ground. So what ends up happening is while the charged object is held close, the neutral object is grounded, which allows for electrons to either move in or move out of the ground. So you can do this with positive or negative charges. So let's take a look to see what happens. So actually, before we even get to that, let's talk about what discharge is again. So remember, the term grounding is the same thing as electrical discharge. So this is where electrons can move in and out of the earth or of the ground, okay? So if there are extra electrons, so let's say you have a negative charge, electrons will go into the earth. If there is not enough electrons and it's a positive charge, the electrons will actually go from Earth to the object. So remember, it goes either way. So when we're using that for charging with permanent induction, we have to keep in mind that it can go either way. Okay, so here we have a neutral object. We bring a negative rod close. So right now, this is temporary, right? So the electrons are repelled away from this negative rod, right? So we have a temporary positive charge here and a negative charge on this side. Now, if we were to add in a ground, so right now, the electrons are kind of stuck on this sphere. They have nowhere to go. But if you were to attach a ground to this sphere, what's happening is you are now opening the doorway for electron movement. So you have to think, this negative rod is repelling those electrons. So what ends up happening is when you cause that grounding wire to be attached, you are opening the door and giving a way out for those electrons to move. So this negative rod is repelling electrons to basically leave the sphere and go into the ground. So what happens is after you remove this grounding wire, so notice they're showing you here the electrons have moved out of this sphere into the ground. Now those electrons have actually left. They are gone. It's lost electrons. So when you remove this rod, the electrons have been lost, right? There's no way of them returning back to this area unless you were to attach a ground again. So right now, this is a positive charge, but let's say we were to attach a ground again at the end. What ends up happening is this would then neutralize, okay? Now remember that when you're grounding objects, we are also grounding material. So instead of using an actual wire, you can actually just simply touch the rod and act like a ground yourself. Okay, so let's take a look at this again. Hold on one second. I'll try and get an animation to have us understand this a little bit better. This is a confusing topic, I know, sometimes for a lot of students. Okay, so let's take a look. So we have here our sphere, and we have the ground, and right now this is a neutral sphere, and we have a negative rod. So let's look to see what happens when we hit play. So right now, let's press pause. Let me pause it. Okay, so before the ground is attached, right here, this is a temporary induction. So if this rod were to be removed away again, this would simply go back to being neutral. So if we hit play, you'll see what happens when we attach the wire. So here is the ground that's attached. Notice the electrons left because they are repelled. And at the end, we have a positive charge that's left over. So let's watch that one more time. So here, temporary induction. But when we add in the ground, we are now allowing those electrons to move out of the sphere. And then, of course, if you remove, sorry, it only gives me a certain amount of time. So then if we have the wire, it grounds it, and then we remove this rod, we now have a permanent positive charge. So the same thing can happen when you have a positive rod, but the difference is instead of repelling electrons to leave the sphere, electrons will be attracted to come into the sphere.